Okay, we are talking about Chapter 3, Section 8, and in this section there's only a couple of concepts that are covered, and then we're going to do a few practice problems. Okay, so the first one is that parallel lines have equal slopes. Now, that's going to be an important factor, and when you look at a picture of parallel lines, it makes sense, since slope is the steepness of the line. When lines are parallel, they have the same steepness. Perpendicular lines have slopes that are opposite reciprocals. Now, opposite reciprocals means that we are going to flip the slope and change the sign. So, if you take a look here, the other thing to keep in mind is that the product of the slopes of perpendicular lines will be equal to -1. This is the way your book likes to take a look at it. I personally like this one a little bit better, but that's up to you. So, in this example, we have 3x minus 8 and -1/3 x plus 4. Notice we only look at the slopes. We do not look at the y-intercepts. So, if you take a look here, 3, which as a fraction is 3 over 1, if we flip it, we'll have 1/3. We change the sign from positive to negative, and there we go. These two are opposite reciprocals. If we take the two slopes and we multiply them together, we get a product of -1. Either way, you can see that the lines are perpendicular. Okay, so let's move on to the examples. So, in the first example, the question is asking you to take a look at the two lines and decide if they are parallel. So to do that, you're going to go ahead and calculate the slope for each line using the slope formula. So we'll call this line 1 and we'll call that one line 2. So the slope for line 1 is going to be change in y, so 3 minus -5, over 1 minus -3. Clean that up and you will get 8/4, which is 2. For the slope of line 2, we're going to go ahead and take change in y over change in x, and that's going to give us 6/3, which is also 2. So, to answer the question, are the lines parallel? We would say yes, they are parallel. On the second example, it asks you if the lines are perpendicular. So again, I'm going to call this line 1, I'm going to call this line 2, and we're going to find the slope of line 1, and it, again, change in y over change in x leads to 3/6, which is a slope of 1/2. Now, to find the slope of the second line, we go ahead and, again, change in y over change in x leads to 9/3, which is a slope of -3. So, just by looking at those two numbers, I can tell they are not opposite reciprocals. But also, if you go ahead and follow your book's rule, if we multiply those two numbers together, we definitely do not get -1. So, not opposite reciprocals, and again, -3 times 1/2 does not equal -1. So are they perpendicular? The answer is a resounding no. Okay, for example 3, at the bottom of the page, we're being asked to find the equation of the line parallel to this line and passing through this point. So when I see this keyword parallel, I think to myself, same slope. So, once I know I want the same slope, all I'm going to keep is the slope of -4. You do not keep your y-intercept. So then, since I have a point that passes through the line, I'm going to write the equation in the easiest form possible, which is point slope, as you recall, looks like this. And then we're just going to go ahead and plug in that point, which would be a 1 for the y, a slope of -4, and minus a -5, which is +5 to finish this off. Okay, we're moving on to page 3. Okay, here on page 3, we're looking at example number 4. And we're looking for the equation of the line that's perpendicular to this line and passes through the point 4, 7. So we go ahead and, again, when I see this key word of perpendicular, I think to myself, hey, that means slopes are opposite reciprocals. So I'm going to take this slope, which right now is -2/3, and I'm going to change it, and the slope of my new perpendicular line, I'm going to flip it, and I'm going to change the sign from being negative to being positive. So again, that's the only thing we keep or we use to write our new line. And I'm going to go for point slope again. So that's going to be y minus 7 equals slope x minus 4. In class, we will talk about how to graph these lines on your calculator and how we can see that they are going to be perpendicular to each other. Okay, we're going to move on to page 4. Okay, on page 4, we're going to take a look at example number 7. It asks you to write the equation of the line parallel to y equals 6 and passing through the point -3, -7. For this type of problem, I like to make a quick sketch, and I can see that y equal to 6, again, would be a horizontal line passing through 6. And that's what y equals 6 would look like. And then the point -3, -7 would be over here somewhere. And so if I want, and again picture it, a line perpendicular to y equals 6, then my line needs to pass through that point -3, -7. And so that line, parallel line, would turn out to be y equals -7. And for our last example, write the equation of the line perpendicular to y equals -4 and passing through 2, 8. So once again, y equals -4 is down here. And 2, 8 is somewhere up here. And I want to be perpendicular to the given line, and that means I would need to be a vertical line. And for a vertical line to pass through 2, 8, that vertical line would have to be x equals 2. And that answers both of those questions. And I will see you in geometry class.